Once upon a time, a boy named Sandro was so bored in his lab that he hypothesized something weird in his time standard. If salt solution is ionic, does it mean its electricity can be conducted too? Well, he was right. Using metal strips submerged in salt solution, he proved his hypothesis, and later on became among the league of greatest scientists by inventing a device pioneer to all electrical connections, a battery. With the advancements he made, humanity was introduced to a yet new concept fundamental to every technology nowadays: circuit. What is a circuit? A circuit is any path confined to itself, having a starting and a finish line at the same place. In electricity's context, a circuit is a closed path transmitting and conducting electricity. There are two fundamental types of electric circuit: series and parallel circuit. A series circuit is a type of circuit in which the electricity flows only through a single path. As there is only a single path for the electricity to flow in, the current is the same across all its components. In return, the total voltage is the sum of all component voltages across the circuit. This is the reason why the device added receives a little power the further it gets to the source. As voltage is directly proportional to the resistance and the current is constant, the total resistance is also the sum of the individual resistances. This is also the same to the total power across the circuit. As voltage and power is proportional, the total power is the sum of individual power of each load. A parallel circuit, on the other hand, is a circuit in which electricity has two or more paths to flow in. As there can be many paths for electric flow, the total current across the connection is the sum of individual current of each load. But unlike series circuit where electricity is somehow distributed across each load, each component receives the same amount of electricity, functioning at the same amount of power, no matter how many devices connected to it. Why? It is because the total voltage is the same across each component. Conversely, as the total current is the sum of individual current, and current is inversely proportional to resistance, total resistance is the reciprocal sum of individual resistances. Series circuit is much simpler than its parallel counterpart, making it the most viable option for high school experiments. On the other hand, it presents a lot of disadvantages too. The more the device is connected to it, the lesser the power the succeeding device gets. The succeeding device also powers down when the other device gets faulty. This is the reason why parallel circuit is more viable for practical applications, like the connection we have at home. Although seen only as a simple science experiment, circuits have so much practical applications that every existing technology we have would not come to where they are today if it isn't for its wonder. Science or magic? Well, I guess only Sandro knows the answer.